Hello dear children, let us start Chapter 3 Laws of Motion Part E Gravitation. In the previous video, we had discussed about force due to gravity, acceleration due to gravity, relationship between small g and capital G, and importance of law of gravitation. In this video, our objective is to learn the following topics: motion of a freely falling body, equations of motion, and comparison of mass and weight. So, let us start today's session. Let us start today's session with the topic free fall. Children, what do you mean by one-dimensional motion? Motion of a body in a straight line is called one-dimensional motion. Okay, so what we call to the motion where a body is freely falling from a height or when a body is vertically moving in the upward direction. Okay, that type of motion is also called as motion in one dimensional, but it is called as motion in one dimensional under gravity. Okay, so that type of motion is also called as one dimensional motion under gravity. Okay, one dimensional motion under gravity. So acceleration of a vertically falling body, in that case when a body is falling vertically in the downward direction, in that case A is taken as, or A is written as plus G. Instead of A, we are writing plus G. Why children we are writing plus G? Because when a body is moving in the downward direction, then the body is moving towards the earth's surface. So A is taken as plus G. Acceleration of a body falling vertically upward, in that case A is taken as minus G, because the body is moving away from the earth's surface. Okay children, here we are having three equations of motions. As I told you, here we are reading about the free fall. That means a body vertically moving in the downward direction or a body vertically moving in the upward direction. So in that case, instead of A we are writing G, and instead of S, that is the distance, we are writing height. Okay, H. So these equations can be written as V is equal to U plus GT, H is equal to UT plus half GT square, and V square is equal to U square plus 2GH. Okay, 2GH. These three equations are equations of motion. That means motion means one dimensional motion under gravity. Okay, now let us consider here two cases. First case is if a body falls from rest freely from a height. That means let us consider that a person is standing on the roof and holding a ball. Okay, now the ball is dropped and the ball is falling from the height. Okay, initially children, tell me what was the condition of the ball. The ball was at rest. So here U will be 0. Okay, so here G is taken as positive or negative children. Here G will be positive. Okay, so here the equations of motions can be written as, we are taking this one because this is for one dimensional motion, and these equations are for one dimensional motion under gravity. So V will be equal to, since U is 0, so we are writing V is equal to GT. Second equation, H is equal to, U will be 0, so half GT square, and third equation, V square is equal to, U square will be 0, V square is equal to 2GH. So these three equations are the equations of motions when the body is falling freely from a height H. Okay. Now let us learn another case where a body is thrown vertically upward. Okay, or we can say that when a body is moving in the vertically upward direction. Here I have written the equations of motions when the body is acting under gravity. Okay, now tell me children, what will happen, or how can we write the equations of motions when the body is thrown in the vertically upward direction? For example, let us consider here a ball is moving in the upward direction. Okay, upward direction. So in that case, g will be taken as negative. The value of g will be negative. Okay, so how can we write the equations of motion here? Here v will be u minus gt, h will be equal to ut minus half gt square, and v square is equal to u square minus 2gh. Okay, when a body is thrown vertically in the upward direction, here g is taken as negative and the equations of motions can be written like this. Okay, now tell me children, what will happen when a body is reaching to a maximum height? Since the body is moving with some initial velocity, after reaching to the maximum height or highest point, what happens to the velocity of the body, or what happens to the final velocity of the body? The final velocity of the body becomes 0. That's why the body takes U-turn. That means the body is moving in the downward direction. Okay, the body is moving in the downward direction and it's reaching to its initial position. Okay, the body is moving in the downward direction. Why? Because at the highest point, the final velocity becomes 0. After that, the body is acting under gravity. That's why it is moving in the downward direction. Okay, so now let us find an expression for the maximum height reached by the body. As I told you, maximum height at the highest point, v is equal to 0. At highest point, v is equal to, at the highest point, v is equal to 0. So we need to find h. So let us take this equation. Okay, so v square is equal to u square minus 2gh, or here v will be 0. So u square minus 2gh, or u square is equal to 2gh, or h can be written as u square by 2g. This is an expression in order to find the height of a body when the body reaches to a highest point. Okay, now what will be the total distance or total height attained by the body in a particular journey? For example, a body is thrown in the upward direction. Okay, that is if the height is h, this height is h, and again the body is coming to its initial position. So what will be the height of the body? That height will be also equal to h. This height will be also equal to h. So now if we need to find the total height. So how can we find the total height, children? Total height will be equal to h plus h. That means u square by 2g plus u square by 2g. That means 2u square by 2g. That means it will be equal to, okay, so total height is nothing but your u square by g. Okay, now let us find the time taken by the body to reach the highest point. So we can take this equation. As we know that v is equal to 0 at the highest point, so v is equal to u minus gt, or we can write 0 is equal to u minus gt, or u is equal to gt. T can be written as u by g. This is the time taken. Now again children, if a body is taking time t, or the time taken by a body is t in order to reach the highest point. Now again the body, when it's coming into its initial position or coming in the downward direction, what will be the time taken by the body? In that case also it will be t. Okay, the time taken by the body to reach the highest point and again coming to the surface. In both the cases, the time taken will be same. Okay, that is t. So how can we find the time taken of this journey? That means moving to the highest point and again coming back to the initial position. In that case, the total time taken will be t plus t. So how can we find t, children? Here already we've found t. T is nothing but your u by g. So u by g plus u divided by g. It is nothing but equal to 2u by g. So the total time taken will be nothing but equal to 2u by g. Okay, so like this we can find the time taken by the body to reach the highest point and total time of the journey. This is the time taken by the body to reach the highest point. Okay, and this is the total time of the journey. Total time means first moving to the highest point and then again coming back to the initial position. Okay. Now let us discuss about mass and weight. Okay, let us differentiate between mass and weight. Okay, the mass of a body is the quantity of matter it contains. How can we define mass? It's nothing but the quantity of matter contained in a body. The weight of a body is the force with which the earth attracts it. That means, or we can say that the force of gravity on it. Weight of a body is the force of gravity on it. Okay. Now mass. It is the scalar quantity. As you know that it has only magnitude. Mass means the matter contained. So it has only magnitude. But weight of a body is a vector quantity. Why, children? Because it has magnitude as well as direction. Direction means it's moving vertically the downward direction, that is towards the center of earth. What is the unit of mass, children? It is kg, but unit of weight is Newton. Okay, why it is Newton we'll discuss later. Mass of a body is a constant. Okay, it does not change with the change in place. But in case of weight, since it depends on gravity, so the value of weight of the body is not constant. Okay, it varies from place to place. Here one thing I want to tell you, children, that generally the mass of the body is constant, but in some cases, like when the velocity of body becomes more than 10 to the power 6 meter per second, or when it reaches close to the speed of light. That is, what is the speed of light, children? 3 into 10 to the power 8 meter per second. In that case, what happens, children? The mass of the body changes. Or it increases. Okay. But when the velocity of body becomes less than 10 to the power 6 meter per second, when it is less than 10 to the power 6 meter per second, then in this case mass is taken constant. Now mass is measured by a physical beam balance and weight is measured by a spring balance. This one you already know. Okay.